right. Welcome back. Welcome back, everybody in the room. Welcome back to everybody online. I'm excited to see you, especially after the lunch break. Some people could take a nap, but no, not here. It's very interesting, hopefully. And I think this debate is going to be fun also because we started to warm up in our experiment, thinking about impact, thinking about different types of impact. How do we measure it? What might some of the tensions be? And this debate will be about the topic. So this debate is special because it's a debate with four amazing people, but also because it's actually co-organized and we're going to have people watching online from the Academy of Management's TIM division. Now, I know that some of you may not have been to the Academy of Management yet. It is essentially the largest professional organization of management scholars, and it has different divisions, and one is TIM, which is Technology and Innovation Management, and that's essentially the kinds of people who study the kinds of things we're doing here, mostly taking management, economics, organizational perspectives. And as one of the representatives who helped us kind of liaise with the TIM division, I would like to ask Kila to come up stage and just say a few greetings before we get to the heart of the actual debate.
Sure. So, hi everyone. Thank you. So, on behalf of Sonali Shah, the head of the TIM division, and Marcus Perkman, Susan Cohen, and myself, we were really excited about the Open Science community and the Open Innovation in Science Conference, and specifically about this debate. And we thought the fact that this is a hybrid opportunity, it enables people from all over to join. And we hope that everyone, online will join us next year when the conference is really taking place also in person. But I think hybrid is also fun. You can join from wherever. So the TIM division, as you were saying, is a large division that really cares about innovation, science, and technology. So if you haven't attended or haven't read, there is a great newsletter that is not too nudging, but it gives all the updates that you needed. And of course, we'll see everyone in Boston in the summer. So thank you very much, and we look forward to the debate.
Thank you. All right, so this debate, and we are throwing around all these different conferences. There's another conference which is called the Druid Conference, and they have like these super sharp antagonistic debates. So this is not the kind of debate where two people have to kill the other two people, and we're going to vote who won or who didn't. So if you want that, go to the Druid Conference. It is a debate that's really kind of taking different people's perspective on openness, collaboration, what could be the impact on scientific and societal impact. And we have four amazing people. I'll introduce them in the order in which they will start their opening statements. And to give you a little bit of the structure, so the idea is everybody has about 9 minutes, non-negotiable, to essentially tell us a little bit about where they're coming from in terms of what's their background that's relevant to the debate, in terms of their scientific research they've done on this, practice that they've engaged in related to OIS. Then there may be a minute or so asking for back and forth question if anything immediate comes up on the panel. And then I have a couple of questions based on what I think they're going to talk about or what I observe. But most of it hopefully will be engagement with the discussion with people here in the room, but also online. So Susanne has set up amazing tools and so on for everybody to share comments and questions. So I think there will be quite a bit of food for thought material for us to argue about and to go home with in the end, hopefully as well. All right, so let me introduce first Michaël Gittelman, who is Associate Professor in Management and Global Business at Rutgers Business School. And she's worked a lot in the kind of medical sciences space, and so we'll hear a little bit from her first. And she's particularly interested in how institutions support innovation, in the biopharmaceutical space. Second person will be Al Edwards, who is the founder and chief executive of the Structural Genomics Consortium and professor of medical genetics and medical biophysics at the University of Toronto. So you may have heard yesterday he brought in the perspective of the people who are doing the science. And I think one of the cool things about us as a community, but also on the panel, is this interplay between people who study science, people who do science, and we also do science, but different kinds of science. So this is going to be really interesting. Third is Dilek Fraisl. So she's a research scholar at the International Institute for Applied Systems Analysis, and you may tell us more where that's sitting and what you're doing there. And she's also the managing director of a big effort to actually bring together different citizen science associations. So it's called the Citizen Science Global Partnership, and a consultant at the UN Development Program Center. So I think this effort to organize different OIS initiatives in the real world is actually really interesting and laudable. So I'm very excited about this one. Last but not least, Michaël, who is Associate Professor for Strategy at INSEAD. And he thinks about how new ideas spread, and he's particularly interested in natural experiments. And we heard yesterday, Matt Marks was mentioning some of the work they've done jointly on thinking how can we identify effects, how can we really say what's true and what's not true in studying science and how science and innovation progress. So each of them has prepared about 9 minutes statements around our question. Again, the focus here is not everything you know about open science, but really what are some of the synergies and tensions that we may have to deal with or that we should think about as we're thinking about bringing in open science practices. And I have had discussions in the break with some of you. When we talk about OIS here, we think about some of the open science stuff that's kind of conventional things, such as open data, open access publishing, but also this kind of collaborative element, right? So thinking about boundary crossing collaborations between different disciplines, between industry and academia, between citizens and scientists. So we think about it quite broadly. And if you want to remind yourselves what all the different things are we are thinking about, read the Bikard paper, which has this big kind of framework that you can put over your bed, and now you remember all the different aspects of OIS. And I'm saying it because you're going to see the panelists talking about different aspects of OIS practices, but they're all kind of fitting in this broader umbrella. All right. On that note, I don't think I forgot anything in terms of getting us started. I'll hand over the word to Michelle.
Thank you. Hey, everybody. I want to thank the conference organizers, and particularly Henry and Suzanne for inviting me. It's really wonderful to be here and be part of this terrific community. Can I get the slides? Okay. So I'm Michelle Gittelman, and I'm just going to put up the question we've been asked to debate. Does open innovation in science practices promote social impact at the expense of scientific productivity? No worries. She's part of an open science initiative.
And the arts.
Or do they help us achieve both? And if so, under what conditions? So that's the question I'm going to talk about. But before I do, I realize we've just had lunch and maybe we're a little sleepy. I want to wake you up with this slide, which was taken at my university about 3 weeks ago when we were on strike. And those are scientists, PhD scientists at the medical school on strike, and just sort of making the point that academic scientists do not live in an ivory tower removed from the pressures of society. I'm going to throw that out there, and hopefully we'll come back to it later in our discussion. So first, does open innovation in science practices promote social impact? Yes. Hard to disagree with this point. Particularly in biomedicine, open innovation and data sharing vastly speeds discovery and saves lives. There's no question, and Healy, you talked about COVID yesterday. COVID is replete with examples of what can be done in a compressed amount of time. Paxlovid was developed in 17 months, rather than 17 years on average for a drug. And a wonderful example of data sharing on the clinical side are the WHO Solidarity trials that involved thousands and thousands of patients to test repurposed antiviral drugs for COVID. And in fact, we came up with new treatments and effective treatments in a record amount of time. And data sharing and drug repurposing was a central part of that. And so do open innovations in science practices promote social impact? In medicine, yes. Medical research is interesting to study for us, I think, because there are so many spillovers, both within fields but across fields, and these are very unpredictable. So the word serendipity has been used to describe the discovery process. And so the more we have archives, the more we have data hubs that pool across different types of data, we can promote faster and cheaper discovery paths for disease research. And talking about different types of data, I'll come back to that. And the NIH now requires a data sharing plan for every grant application. So resounding yes, and now let's go to the next part. Do these practices promote social impact at the expense of scientific productivity? No, they should not. Publication races are a key reward mechanism aligning strategic career choices of individual scientists with the goals of collective advancement. And I want to read quickly this one of my favorite quotes from Derek de Sola Price. Scholarship is a conspiracy to pool the capabilities of many men and women and others, and science is an even more radical conspiracy that structures this pooling so that the totality of this sort of knowledge can grow more rapidly than any individual can grow themselves. So I do not see a conflict here, and these data sharing requirements, such as through the NIH, create a kind of level playing field by requiring everyone to do it, and are creating new sharing norms across different scientific communities and across individuals who may be more or less reluctant to share. Okay, now where's the but? Under what conditions? So I want to talk about two conditions that might misalign this natural complementarity between social impact of data sharing, I'm talking about data sharing, and individual productivity. And one is variation in the cost and speed of experiments. And the second is, relating to the earlier slide I showed you, precarity, the structural insecurity that most scientists face now about the continued funding of their commitments to experimental paths, and that fields using human subjects data are particularly vulnerable to these potential tensions. So I want to talk about the first one, the variation in the cost and speed of experiments. And I think that thinking about this type of variation, both within and across fields in the kinds of experimentation you do, is actually a lot more useful than thinking in terms of basic or applied research as meaningful categories. And so if we think about individual scientists, in their careers, they have to commit to a series or a path of experiments. And these experiments vary both in terms of their cost, but also their timing. And longer projects that take more time until publication are inherently more risky. And so we can think about longitudinal versus cross-sectional. We can think about computational modeling versus human subjects data. And diseases themselves have different timelines that are important. So one of the reasons we came up with COVID drugs so quickly is that the life cycle of the COVID virus is extremely short. But if we have complex diseases like Alzheimer's, or long-term cancers or environmentally caused diseases, those take many, many years, and a scientist has to really build a portfolio across these different types of timelines. And so I have this seesaw that shows, on the one hand, the speed of publication increasing on the x-axis and the cost of data increasing on the y-axis. I think this relates very much to our discussion yesterday with Matt Marks. An academic scientist really has to choose where to land here. And there's a lot of institutional pressures to land in the lower right. Especially increasing reliance on what we call soft money and grants, and not just grants, but grant renewals to pay for everyone in the lab and provide careers for everyone in the lab, puts more pressure on scientists to focus on experiments which we have a more certainty of publication in a shorter period of time. And so the question, and so I just put up some fields here where we might see medical science pushing down towards the lower right. I also threw out some patent data for our own field. Matt talked about the MBER data set that was shared. There's been an explosion of work on patent data, but potentially less work using field work and ethnography, which are essential for understanding complex organizations. And in medicine, we can think about epidemiology, academic clinical trials, and longitudinal observational studies. So the question I pose on this tension is, will data sharing requirements further bias scientists' choices towards the lower right, resulting in less research using human subjects in long-term studies? I think I'd want to call your attention to some very important evidence from the private sector. This is by Heidi Williams and colleagues. And they found that when you have a fixed patent term, when you have a clicking clock, Firms invest more in late-stage cancer drugs because the clinical trials are short and clear. But they underinvest in early-stage cancer drugs because the length of the trial is too long and the milestones are too uncertain. And they estimate lost life years here at close to 1 million. I think we can make an analogy as well for academic scientists. I'm going to quickly take you through this one study as an example, which is the Chicamo study at Berkeley. It's the longest running birth cohort where they followed mothers from pregnancy into adulthood of their children and collected a huge amount of data on these children. These are agricultural workers in Salinas, California, and they found that the chemicals used in the crops were associated with diseases in the children at age 20. And the study was published. But this study was targeted, and I'm just throwing this out there because I discovered this in the context of looking into this topic, so thank you for that. The Trump administration introduced a rule to bar the use of studies if the primary human data is not shared, the primary data, even though legally they couldn't share this data. So yes, as discussed yesterday, validation is essential, but rulings like this tip science that is used to regulate industry towards molecular and animal studies that are by their nature much more limited in what they can show. So, I'm not going to read these slides, but I think the challenges here are that all data are not created equal. Some data has more value and it costs more than others, and they are complementary. The value of high-end computational data really depends on clinical validation. We need both. Data sharing rules could create further bias against observational longitudinal research and tip scientists away from doing more of that research. At the terrible extreme, clinical trials will shift immediately to the private sector where we have no data, very little data. And so we need mechanisms to ensure that observational research remains attractive for academic scientists, incentivize primary data collection, share costs of collecting and maintaining the data, which is quite expensive in that space, and on my wish list, to stabilize scientists' funding sources to encourage high-risk, long-cycle observational research. Thank you very much.
Thank you. All right, I moved here so I can be in the speaker's face with my time cards. Al, you're the next.
I have to wait for my slides, I think. Hi, I'm Al. I'm a scientist.
And that's okay.
I'm going to say, I was about to say a real one, but I didn't. That was my inside voice. And so I'm going to speak today about the role of universities play in the research and its interaction with industry, focusing on the pharmaceutical sector, in which that's the sector in which I work. And so the general thought about how we should deal with our data at universities, I'm going to make the argument that there's no evidence at all that patenting helps. Okay, and so this is a more general thing from The Economist a bunch of years ago about the patent system in general, but I'm going to be speaking specifically today universities and patenting. Okay, so Heidi did a really good study, this was ages ago, where she took the human genome and she looked at the genes that were patented and the genes that weren't patented, and they were a large set of thousands each, and then tracked commercialization from that knowledge over the next decade, and found out that the genes that never were patented, so a lot of times they were patented and the patents sort of went away, that had never been the subject of a patent application, had 30% more commercialization activity. So the freedom to operate of having a clear field was in general. And so that's what she said, that Celera's IP led to the reductions in subsequent research and product development. This is from Levine, I think he's at St. Louis, and this is true. And it's funny, we have this big, patent thing at the universities, but there's no evidence for it. It's really bizarre that we're evidently evidence-based, institutions in universities, and yet deny the facts, and I'll show you some evidence for that. So why is there so much evidence on universities and patenting? Does it drive economic growth? No, this is from a countrywide perspective. Does it drive professors to innovate? I can tell you, no, that's not why we go to work every day. Is it consistent with the university mission? At least University of Toronto's mission is justice, equality, and fairness. It doesn't say anything about spin-offs and anything. Does it drive economic growth? I said that. Are they indicators of innovation to government? Absolutely. It's measurable, and governments love it. And so when we get funding, because in Canada, all the institutions are public institutions, and so there is a easy argument to government to give us more money because we innovate, which means we patent more. Are they required to raise money from VCs? Sometimes, so yes. So this is the venture capital wagging the university dog, right? So the venture capitalists will say, oh, I need a patent, even though they don't commercialize ever the foundational patent from the university, because we hardly invent anything of use at universities. It always requires subsequent innovation, and usually that occurs in the private sector. But because to get the initial seed funding, they need something, and a patent is sort of the chit. So let's talk about some data. So these are the AUTM data from Canada, and looking at tech transfer over all our universities combined. And I should say that the funding at the time for Canadian R&D at universities was $10 billion. For $10 billion of R&D, we made $57 million in licensing revenue from our intellectual property portfolio. This is the sum of all Canadian universities combined. So it's a rounding error, but it's worse, because we said $55 million to make that 57 in funding the tech transfer offices. We also fund these innovation hubs around universities. So it's commercialization help to transfer all that brilliant idea into reduction in practice and blah, blah. We'll create the economy of the future, blah, blah, blah. And so we're spending $10 billion in R&D, $250 million in help, $55 million in actually funding tech transfer to make 57. And then you start to add in the costs of material transfer agreements. So we exchange knowledge and things at universities, because if you invent something at the university, it belongs to the university. If you want to give it to your buddy at another university, you have to execute a contract called a material transfer agreement. It takes about 2 months. In Canada, we execute about, I would say, 6,000 to 10,000 of these each year. So if you want lost opportunity, 2 months of time times 6 times that's $40 million in just waiting for something. I'm just transferring something of no commercial value from me to you. And it's just that delay. On average, it takes that long. So it really is negative. There's no evidence that this helps in any way possible. So University of Toronto as a test case, that's our operating budget at the university. This was 10 years ago. R&D budget was $1.2 billion. It's the largest university in Canada. That's how much money directly we get in research from industry. It's a small number, but it's $87 million. That's how much the campus, so most of it goes to the hospitals in the clinical trials. And that's how much from licensing. And it fluctuates every year because of it's, depending on the invention. But no business person will go, hell, that's a good deal, right? Especially all the time we spend in sort of creating an infrastructure to do this stuff. And again, if you look at our university mission, justice, fairness, equity, it doesn't say anything about this. So is there another way to translate? So I'm going to give you some examples from the organization that I run and from the Montreal Neurological Institute. So the SGC is a charity. It was set up 20 years ago. It's funded by the pharmaceutical sector and charities and governments. And one of the core principles of them are we never file for patents on anything. And we have research labs at 6 universities. You see them on the bottom left. And we've probably gotten about $250 million in funding from pharma explicitly to put things into the public domain without restriction. And so with that money, we start to make these proto-drugs, which are these chemical probes, give them away. So we've distributed 50,000 samples. Professors get them, squirt them on their cells, find, oh, that's a good cancer drug. And so then they publish it, and they get all the citations. And then the companies go, oh, my God, I never realized that could be a cancer drug. I'll start an internal drug discovery program. And there's at least 80 clinical trials ongoing now on the scientific discoveries that we made with the tools that they help us make. So it's not just funding, they actually collaborate with us. So Guy took the learnings from, he was on a Canadian panel that studied our organization, as did Marcus. I don't know if he's on there. Hi, Marcus. And so it comes down, and so Guy's the head of this large institute within, it's a hospital institute within McGill University. And he said, why are we worrying about this patent stuff. Let's just make our whole institute patent-free so we can collaborate with everybody. And so at the bottom left, we're doing a really shitty job, he said, because it's not trying to do that. I can't even read it, due to the complexity of the problem. So he works on ALS. He's an ALS clinician. He says, I'm treating the people the same way I did 30 years ago. And he got, so he was excited he got the word shitty into science, but I beat him because I got 2 times shitty into science. And so, oh no, this is nature. And so I beat him on the shittyometer. But it's a super interesting test case, right? Because you have an institution within a university that has declared itself that we will not file IP on any of our discoveries. And what happened was, got more industry funding, got more grant funding, it got more philanthropy, and they say, this one's harder to quantify, the recruits that they get are higher quality, right? Because I mean, the industry's easy. Okay, I don't have to deal with any of those negotiations. It's a very clear deal. I get freedom to operate. There's going to be no complex negotiations. The grant funding, I think it's because of the ability to ask more focused questions with industry. Philanthropy, everybody buys into openness and peace and love and stuff. And the high quality recruits is because when they're trying to recruit a new professor and he or she's got 4 job offers, going into an institute where this is the ethos, it turns to be a good recruiting tool for students and postdocs and young faculty as well, even old farts. So that's it. Thank you very much, and on to the next one.
Thank you. Do you want to come up, or either way? Good.
I think it's better I stand. So, hello everybody. My name is Dilek Fraisl. It's great to be here, and I would like to thank the organizers for inviting me to be in this very interesting discussion. I will be talking about citizen science and impact and open innovation in science today. So let's start with the term citizen science. We've been hearing about this term throughout the conference, but may I ask you in the audience, how many of you are feeling that you're really familiar with this term, what citizen science is? Can you just raise your hands if you are? That's very good. What about crowdsourcing? We have even more. Community-based monitoring? Nobody? Participatory action research? Have you ever heard of it? That's great. Wow. Then I can go home, maybe. I don't need to talk about this so much. So that's great. But I know you know where I'm getting at with this. So there are various terms to describe these citizen engagement in knowledge production activities. And in our work at IIASA and at the Citizen Science Global Partnership, we take an all-encompassing approach and define these different practices as public participation in scientific research and use citizen science as an umbrella term to describe all these diverse activities in an inclusive way. So the fact that there are so many different terms to describe similar activities is because they all come into existence in different contexts, and they reflect the peculiarities of this context in which they originate. For example, citizen-generated data is mostly used in the context of civil society organizations, while citizen science is more science, academia-oriented, right? And you see some examples of citizen science activities, some famous ones, such as bird monitoring or beach cleanups, and so on. And let me get to the next one about the impact. This is really relevant to what I'm going to talk about on the impact side of this presentation today. So you know this, right? These are Sustainable Development Goals. How many of you are really familiar with this? Sustainable Development Goals. That's good. That's really a good audience today. So Sustainable Development Goals are a global call to action to address the world's greatest challenges, from environmental degradation to gender inequality, right? They were approved in 2015 by the UN member states to be accomplished by the year 2030. And they include 17 goals and 169 targets. So we're talking about a pretty ambitious agenda here. But the fundamental question with the Sustainable Development Goals is, how do we know whether we're reaching these goals and targets, where we are today and where we need policy improvements and changes to be able to ensure or make sure that we're actually going to be there by the year 2030. So we need timely, reliable, and accurate data to be able to do that. So to reflect that, an indicator framework was approved in 2017, and this included 232 unique indicators at that time, and this number is today 231. So we're talking about measuring 231 indicators covering all these diverse topics in all the countries doing these measurements. So this is a huge challenge. So, for example, just to give you an idea, in the Sustainable Development Goals indicator framework, there are 92 environmental SDG indicators, according to UNEP, and 48% of them lack data today, 8 years into the SDG process. And we're talking about achieving all of them in the remaining 7 years. So we were suggesting that citizen science, also with other new sources of data, I'm sorry that I'm turning my back to you.
It's okay.
So, such as Earth observation data and mobile data, for instance, has a lot to offer to address these data gaps, right? So we found that we looked at the SDG indicator framework and the metadata and methodologies of all these indicators, as well as we looked at the citizen science initiatives, the way I described citizen science at the start of my talk, and at the local level, at the national level, at the regional and global level. And we found that citizen science data are only contributing to the monitoring of 5 SDG indicators, and these are mostly in the area of protected areas, biodiversity monitoring. But they can actually, these data can contribute to the monitoring of 76 others. So we're talking about a huge untapped potential here. So we found that 33% of the SDG indicators can actually benefit from citizen science data. So we were very much interested in understanding whether these results are actually applicable on the ground, because this is a very innovative approach. We're talking to the national statistical offices, official statistics communities, who have never heard of the term citizen science before. Some of them were hearing citizen-generated data here and there, but they think that it's only about advocacy purposes, or most of them, right? So we wanted to understand whether our results are actually applicable. So we partnered up with the Ghana Statistical Service, Environmental Protection Agency in Ghana, UNEP as the custodian agency for this particular indicator. We did this study, as well as many other global partners, but particularly these local citizen science groups in Ghana that are collecting the data on this topic. And the topic was the indicator 14.1.1b on plastic debris density, which is beach litter. So this project was about leveraging already existing beach cleanup data for the official statistics and official monitoring, reporting of this particular SDG indicator. I'm not going to be able to go into the detail of the methodology, but I'm happy to talk to you about it if you're interested during the breaks. But our results show that citizen science data for monitoring beach litter actually was, for the first time, have been integrated into the official SDG reporting mechanisms of Ghana. And Ghana has become the first country in the world to report on SDG indicator 14.1.1b, and first country to use citizen science data for that purpose, and by using open data from these beach cleanups. And what is also really important in our context, we're talking a lot about societal impact, but we're also working on policy impact in our research. Citizen science data will serve as inputs to Ghana's integrated coastal and marine policy, which is under development right now. But the most important outcome for us of the project was we were able to bridge very local level citizen science data collection activities with the global official monitoring processes. This is an important outcome for us because many of these citizen science activities are actually happening at a very local community level. And so coming to the end slides, open innovation in science can increase scientific and societal impact of research. I would say depends. So just because we're doing citizen science or participatory approaches in our projects doesn't necessarily mean that we will achieve societal impact, we will achieve policy impact. And there are a lot of important things to consider to make that happen, but most important thing is building trust in these open and collaborative processes across various stakeholders, because we have to work with these various stakeholders. So in our case, it was the government agency, it was the civil society organizations that collect the data, scientists, us, UNEP as the global monitoring mechanism for this indicator. But how can we build this trust? So ensuring inclusiveness through meaningful engagement of all stakeholders, not just for the fact that we engage with people, not for the sake of saying it, but really meaningfully engaging them in the process. And this can only happen by listening and understanding the motivations, interests, and concerns of each stakeholders. So everybody comes around the table with different interests. So civil society is interested in resolving or solving the problem of beach litter in their own communities and beaches, while the government agency, National Statistical Office, is more interested in ensuring the data quality, right? Which is understandable. And for that, we need to create the time and the space for these stakeholders to meet and connect. So we started this project for about a 6-month project, because from a scientist perspective, we have a deliverable, we have a timeline that we need to deliver. But this is not the case when you're working with diverse stakeholders. And it's very important to be transparent about citizen science results and methodologies, especially about how these methodologies were implemented on the ground by these citizen scientists, right? So we can't oversell citizen science. There is problems. There will be problems with data sets. There is no one perfect data source or data set, but we need to be open and transparent about where these problems or where these issues can be, so we can mitigate them all together as this group. And when we talk about citizen science, we tend to look at it, trust from a government perspective, whether we can trust the data quality, or a scientist perspective, but we tend to forget the importance of our citizen scientists. So it's really important that citizens and communities, or to know that, to understand that for the government actors, for the scientists, citizens are no free labor to close governments or science data gaps. They are there to help. They are part of this community, and they should receive a share benefit from participating in these activities. I'll stop here. Thank you very much.
Michaël.
All right. Well, good afternoon. Thank you very much for having me here, and thank you for coming. I'm Michaël from INSEAD, and I guess I was asked today to be a little bit more critical toward open innovation in science, which is not the most straightforward task, I think, both because we are in a conference organized by probably a lot of believers, and second, I think there is even culturally a bias in favor of openness. We think we are, I don't know if we are hardwired, but at least we think of openness as a good thing in general. And to be fair, I think there is a lot of good reasons to think of it as a good thing in science. There are a lot of evidence that by being more open, we can have more cumulative innovation, we can have more replication, we can have more people involved in the production of new ideas. And a lot of people in this room have produced work that shows exactly that. And in fact, even I have to Matt put my small piece, my small stone to this edifice with publishing a data set of scientific discoveries, of idea twins, for other people to use it. No, people are not using it, but that's another story. Well, that's actually not another story. That's the same story. So this is my true stance, but I still want to be a little bit more critical moving forward. And I want to start by trying to think about what could possibly be wrong with this idea of open science. And the first thing I want to say is, there's probably nothing wrong with open, but isn't openness already in the word science? Can we think of science as a not open institution? And I'm going to argue that, in fact, no, science is all about sharing ideas. Starting from antiquities, people would just go to hubs of learning and just share ideas. And then they would write books so that ideas could be shared not only across people, but even across generations. And then they would put these books in libraries, and then suddenly we can have ideas, more and more people can have access to the same ideas. And then with the printing press, we have more and more books that are going to allow people to share their idea even more. And in the 17th century, people come up with a great innovation, the scientific conference, for the scientific societies, people come together to share ideas. And because we don't want the idea to get lost, we're actually going to write them in papers. Another scientific publication is born. We all love that, right? And that's all about openness. That's all about sharing. Everything in science is all about sharing. It's very hard to think of science without thinking about sharing ideas. So we can think of openness in a very narrow way. What I'm going to try to do here is try to take like a few steps back and think about openness as actually a fundamental part of INSEAD as an institution, and especially one that is part of a broader political economy, a set of technology institutions that allows people to share ideas over time and over geographies. And if we think of openness that way, we start, in a broader way, we start to think about potential issues with overstating the power or the benefits of openness. And I just want to highlight two of those issues here. The first one is about reward, and the other one is about quality. Now, when it comes to reward, I love that was actually the first comment after Matt's paper, right? So like, you know what? Openness is costly. Openness is costly. Now imagine for a second that your PhD students, you've worked 5, 6 years of your life to produce this unique, amazing data set that no one else has. And here comes the openness police, like tapping on your back and say, now you're going to make that public. That feels wrong, right? That feels wrong. Why does that feel wrong? It feels wrong because if someone invests 5, 6 years of their life to produce a unique data set, they should be able to produce not only 1, maybe 2 or 3 papers based on those data. Otherwise, they're wasting their time. Right? And if you don't let them do that, then no one will ever produce these kind of unique data sets. These kind of data are just, for instance, part of what Latour would refer to as the cycle of credit in science. Right? In science, data is worth something. You can exchange it against co-authorships, so you can exchange it against actual papers. You can exchange ideas against citations. We trade those things all the time. And if you have enough papers or enough authorships in the bank, then you get tenure. Right? This is a political economy. This is a parallel economy. We exchange these kind of things. This has value. If we put it up for everybody to grab, then people are not going to invest in producing them. Right? It raises parallel questions about who is included, right? In terms of co-author, who gets offered to be a co-author, going back to Caroline and Henry's papers, etc., and for what reward, and all the inequalities that go with it. So reward is the first issue. We do not have in our field a journal that is specifically focused to producing data. It doesn't exist. Maybe now you start having SMJ that will they will accept a little bit for this data, but there is an institutional void here. We have somehow decided that theory is more important. And so yes, we will give you a lot of credit for having a new theory, and we'll publish it in top journals, and we'll give you tenure for that. Great. But if you are producing data, you do not get any of this. It doesn't have to be that way, but that's the way the institution works. So asking people to produce data and be open and all these things is great, but then you have to think about the institutional context around it and reward those people for the work that they do. Otherwise, no one will produce those work if we think this is valuable. All right, that's the reward part. Now, let's talk a little bit about quality. Who here has a paper published that gets very few citations? Okay. Who has here many papers published that get very few citations? Right? This is work that has been vetted by reviewers, by journals. Most science out there is not getting used anyway. And we're talking about vetted stuff. Worse than that. Most science out there is not even replicable. Now, think about the position of someone who is thinking about, okay, what shoulders to stand on, right? What other thing that they use? There's just so much science out there. How are you supposed to know which one you're going to build on? And we're talking here only about stuff that has been vetted and published in top journals. Now we're going to ask people to put their stuff openly out there without any system, any institution to make sure that this is a decent quality and that people are not wasting their time trying it out. This has a cost. This has a cost for us as an institution. And the outcome for this is increased inequality. And that's a very nice paper that is forthcoming by Megan McGarvey and Caroline Fry in Management Science. Highly recommend it. It was a reading about preprints. And where they show that in the preprint world, how do you know what preprint paper is worth your attention? You just look at the authors. If the authors are famous, you're going to read the paper. If they're not famous, you don't read the paper. When the paper went through peer review, now you know that this is good. You can just look at the journal and not really care about who the authors are. What that means is that open science increases inequality because there's so much information that people will focus on who they know, and who they know will be the famous people, so the famous people will get more attention in an open science system than the place where their work has been vetted in a review. That's what they found. So, conclude with this quote: "Open science is the natural evolution from science to the digital age," by Michael Nielsen. Of course, I asked ChatGPT for a good quote about open science, and the quote sounds good, right? But of course, it's fake. Do not ask ChatGPT for quotes. And do not ask like ChatGPT which of those quotes they give you was hallucinations, because ChatGPT is very kind of mad at you for that. But all the quotes from ChatGPT are hallucinations, on average. Anyway, so open science is exciting, but I think that an overly simplistic view of open science is actually very dangerous, right? Because openness should be part of a set of institutions, and just creating an openness policy is going to force people to publish their data to get published in a top journal. It will backfire. People will not invest in producing quality stuff if they know that they can only use it once. Right? So yes, for open science, but no for just creating a police and just like creating a norm of like forcing people to do it. We need to create a set of institutions that are going to actually provide the carrot as well as the sticks for people to actually benefit from being open. Thank you.
Thank you. So thank you all for these super interesting comments. It may sound like they come from very different directions, but when you think about it, they connect to the open innovation and science umbrella, and I'll make another comment on this one in a second. And there was an interesting kind of interplay of the idea of sharing openness in the sense of we have something that we want to bring out, but also in terms of who is actually generating those things that are to be shared, for example, in the citizen science example. And let me kind of use the opportunity to kind of put us back in the kind of back at our paper kind of framework. And I thought the comment also in the break, oh, open science is always open. And yes, but I think when we talked about open science historically, we talked about the openness of the results, right? You publish a paper, you make it accessible. If you're a PhD student who was forced to read Merton, it's kind of this kind of norm of universalism and communism that you can all build on the results, but you did not get a right as per Merton to use the data when to write a competing paper, for example, right? So I think as we're thinking about openness in our context here, let's think not so much about the obvious openness, which is, yes, the paper has to be open access or the paper is published, but really about this kind of the more novel pieces, which are, I'm going to give you my materials, I'm going to give you my data, even before I've exhausted it, which as per Michaël, may be many years. So that's kind of one point to really kind of focus also in our discussion on this kind of more extreme form of openness, if you want. And again, the other one is this kind of collaboration element, and I want to highlight kind of two different versions of collaborations we heard about. One is maybe the more conventional one in our community, which is kind of industry, academia collaborations. How can can we kind of facilitate this? A consortium would be an example. We've seen other examples in paper discussions. Another one is the collaboration between citizens and scientists, or citizens and policymakers. So we think, Chiara and I, when we kind of thought about this kind of crowd science element, really thinking about opening the boundaries of who is allowed to participate in the scientific process. So I think it's good to think about what specific elements of open and collaborative science we're thinking about. Now, I did this not just to clarify the distinction, but also because my first question to you guys is, how might these two things actually be connected? And I saw kind of two connections. And when Al made his comments against patents, so to speak, I was thinking, oh, but we actually teach in our PhD programs for scientists about the patenting process, because we think patents are important to facilitate the collaboration between academia and industry, right? So what some people may think of as being more close may actually facilitate another aspect of open innovation and science, namely the collaborative aspect. And Al already shook his head and he told us in the slides, it does not help. And you were actually saying that companies are happy not having the patent stuff to deal with because the negotiations are too complicated. So let me ask to you, to what extent do you see a connection between these two elements? That openness either facilitates collaboration or makes it more difficult, or flipping it around, to what extent may collaboration between different kind of stakeholders, different kind of scientists, may help us be more open or may prevent us from being more open? So this connection between these two elements of our overall framework, what do you think about it? The most obvious one is this question of, do we need to be open to collaborate across boundaries, or would some limitations to openness actually be relevant? And that goes back to Michael's incentive issue as well. So something along the lines of, how can we connect these two different elements? And I'm gonna just, whoever raises their hand first is gonna.
So I'll speak about the reason we're talking about open is because in the 1980s we went closed, and universities, because it started in America with the Bayh-Dole Act. Remember, I don't know, for background, when universities became more little industries, it was triggered in part by the Bayh-Dole Act. Prior to that, as you know, when you make a patented invention, if the two of us invented something, unless we had an agreement up front, you could license it to Fred and I can license it to Barney, and then the value of the patent's less because we've independent, there's no exclusivity. And then the government, prior to that, the funder also had some rights, and it was super duper complex to get an idea, or if it was a patented idea, from the university out because there were multiple inventors. And so Bayh-Dole said, okay, the government's out of it, universities, you take care of it. So universities, oh crap, now we have to be in the patent game. And so they created an office to do it. And they said, I got an idea, if the university owns it, then there's a single negotiating person with the external world. And then the money would flow back to us. So then they started this process of creating tech transfer. Then they said, oh my God, we're spending a lot of money on this. How are we gonna know if it's good or not? Oh, we'll count patents. And then they started to put it into, and then we started to make arguments to our government, especially in the 90s when the economy was tanking, that we're the sources of innovation, of economic growth for the world. And they pointed to the biotech sector. And then all of a sudden we are where we are today. So we've actually constructed this barrier to collaborate in the last 20 years. So what the openness is just sort of going back to how it may have used to been. And what we've noticed is that there's no evidence that a company wants intellectual property from the university. There's these surveys that have been done with university, with industry. What do you value the most? Access to young people, cool ideas, want to be part of the action, internal motivation, maybe IP. It's always fourth or fifth on the reason to interact. But it's bizarre. We've constructed this legend of why it's so important from anecdotes and very rarely look at the big picture. It's really shocking to me how we can be so non-evidence-based.
Interesting. I think we have a lot of economists in the online audience, maybe, and maybe in the room. It will be an interesting discussion, certainly here, but also maybe in coffee breaks and later on, to think about what's the evidence on this institutional mechanism of patents, which is presumably as an incentive mechanism, as we teach it, is an interesting mechanism. Michelle?
I think I may have forgotten what the two things are that you talked about. But
the collaborative element and openness, and whether they're intersecting.
So I think we really have to solve this puzzle of the incentives to collect primary data, especially if it's costly, and if the expiration period on it is quite long. The whole thing about the norms of science is that by gifting the community with my results, I gain, and my postdocs gain and my lab gains, you know. But if you now have to share your data and others can publish at very low cost over your efforts, potentially scooping you or your students, that creates real conflicts, and also who shares the cost. So I'm just repeating what we had said, but I want to give you, I think that if we have kind of some ex-ante sharing understanding, so for instance, the lab I mentioned earlier, the Berkeley lab that did the maternal studies long-term, was part of a consortium organized by Oxford University to study pregnant women and COVID. And they contributed their data, and Oxford published off it, and they were gifting this COVID community with the data. But that was understood under the auspices of a well-coordinated, centralized structure of sharing, not just like, oh, so-and-so from so-and-so calls and wants you to use the data that you spent 30 years collecting.
I kind of see this interesting, and again, as an economist, the idea is we restrict access, we don't make the data public right away to give people time to produce their papers, and that creates incentives. Now I'm thinking about Dilek's example, where it's the citizens collecting the data. They don't want to publish papers. What's the role of openness in the sense of we ensure that all the data become public in making what you described work? Is it a hindering factor, an incentive mechanism, either positive or negative? How do you think about this in the context of the projects you described?
I think citizen science is a different concept than patenting and a lot of other things that we're talking about, but it also has synergies with what we're talking about. So in our work, we also aim to publish and open, and most of it because of the funders or the funding schemes that we're working in. So we have to make the data open and public. And I think it's the best way to give back to the communities, because once they contribute to this data, their data, to our work, and we make it openly available and public, and then we can produce these kind of results, because we used, in this example that I gave, the data that is publicly available to basically, hopefully, to their own benefits, because it was picked up by policy, and it will inform policy planning on this particular issue in the country. So I think it's very important in that context where, as you said, this is both sides are really relevant on citizen science. We're not only talking about publishing open, sharing the data, but we're also talking about collaborative processes in citizen science. But I think it's the best way to give back to the communities that are actually contributing their data to make it openly available. And we tend to talk about the cost of making the data openly available to us, but we're not talking about the cost of not making the data openly available. So there's also a lot of additional scientific effort that will be put into it if we do not make this data openly available for others to work on. Thank you.
Good. Michaël?
Yeah, lot of thoughts. I guess, okay, so I view it as there's a supply side and a demand side. On the supply side, you're the producer of the stuff that's going to be made open. You need some kind of mechanism to reward you for your work. We could decide as a field to reward people for producing, say, data. But at this point, we don't, or at least we're just starting maybe with SMJ. And even with SMJ, I mean, it's not clear that those papers count the same as a real paper. Sorry? Oh, sorry. SMJ started very recently to publish data papers. So if you have a new data that you want to make public, you can submit it, not the data, but a paper that describes the data to SMJ, and both Matt and I have done that, right? But it's not clear that you get that much credit for it when you go for tenure, right? So yes, it starts counting, but there is a nature method out there. We don't have that in our field. This is, institutions are man-made. They can be changed. It takes some collective kind of like action, but there is no, at least I cannot think of a good reason why we put so much more emphasis on theory that we do on data. Put that out there. Now, going back to this issue of patenting. Why do we have patents? Why were patents invented? Patents were invented to provide an incentive for people to share their idea. Patents are about openness, right? originally, the alternative to patent is secrecy. If you do not provide people patents as an institution, then at least there is work out there, and I'm thinking about, who's that? Can't think of her name right now. An economist, economic historian from Stanford. Anyway. That in the field where there is no patenting, people will just use secrecy instead to protect their ideas. So patent provide an incentive not only to disclose, but also to make sure that to take care of some of the reduction to practice. Right? Openness is one thing, but you may not necessarily have an incentive to produce something high quality. So to take a bit of a counterpoint to what Aled was saying, if you do not provide an incentive for faculty to produce science that's going to be solid and reproducible and usable by industry, which takes effort and resources and time that faculties don't necessarily have, and that's not required to get your paper into Science and Nature, they just won't do it. It would not be rational for them to do it. So we need some kind of institutional solution to this, and patenting might not be the right one. Maybe we can think of something else. But we cannot also expect people to produce very high quality stuff when they could get away with producing a lot less good stuff and getting the same reward. That would not be fair.
So my takeaway is we have to think about incentives, and I think some people in our community think about patents as providing very strong incentives, and we got some pushback on this. So we should open up our thinking about what are the different kinds of incentives that could operate, and maybe what does it depend on, right? It might depend on the context, on the field, and so on. Michelle?
Yeah, I just want to add to this issue of rewards, and Michaël, you mentioned the lower rewards for publishing data, but I am all for sharing data, particularly in medicine. We can only gain by that because we need validation in every field. If we don't have validation of results, science goes off the rails and it does become a popularity contest. But so until validation studies count towards tenure or count towards career advancement, all the data sharing in the world is not going to help. So validation studies have to be rewarded and encouraged.
Yeah, and I think there is some of you, and we may have a session on this, on the institutional environment for OIS practices. And in some sense, what I'm hearing is the practice itself needs to be thought of in the context of tenure systems, evaluation systems, and so on. And that's certainly a topic we could pursue as well. I have one more question, and then I'll open it up to the audience here, but also online. Kind of getting to the second point that Michaël kind of had on his last slide. One was incentives, and we just kind of covered another aspect of this. The second one was kind of quality. And I think we may have different feelings about OIS practices, because some of us feel, oh, this is actually good because you collaborate, more people, there's more eyes looking at stuff, validation and so on could have been seen as a way of increasing quality. But then some people may see, and we saw that earlier in our experiment when we looked at different studies, where people are saying, oh my gosh, now you're getting these parents and patients in there, that's going to be crap. They don't know what they're doing, right? And so maybe, and Dilek, you kind of have the enviable position of knowing so much about citizen science, where I think these issues come out quite a bit. What's your thinking about, because again, this is about tensions, right? It's not about highlighting all the good stuff about OIS, but really thinking about some of the potential concerns and tensions we may have. In your experience, have you seen this tension of bringing in more people, maybe good in terms of having more data, but the quality goes down? Or you mentioned this issue of trust, policymakers don't believe it. How do you see it, and how do you resolve this tension in your project? And more generally, as we think about collaborations, do we think they are uniformly positive for quality, or do we actually also see tensions? And if so, how could we resolve them?
I think a lot of the discussion, so I talked a lot with the national statistical offices and the UN agencies that are really are very, very attentive when it comes to data quality, and I receive this question a lot. But it's always about perceived understanding of data quality. So people have this perception that the data quality will not be so good because it's simply because it's produced by non-experts in the field. So they are judging the whole field, basically, based on the perception of non-experts producing the data, and the quality is not so high or may not be so high. But my response to that, and will be the same here, I think we really need to start looking into the individual examples of these citizen science projects. Like in any science project, there are good, well-designed scientific projects. There are well-designed data collection activities, but there are also not well-designed, not so good designed scientific projects. In citizen science, it's the same thing. So I think we need to get away from these general conceptual understanding of, oh, citizen science, oh, volunteers, not good quality, but instead look into the specifics of each and every example that we want to work with. We do a lot in our own citizen science projects that are mostly around land use, land cover monitoring to ensure data quality. And there are other colleagues that are working in different fields that they do a lot about how to ensure, how to make sure that the quality that are produced in their projects are really high, so that they could be used for official monitoring purposes and so on. So this would be my advice.
Maybe the other two, I think, Michaël, you alluded a little bit to this idea that you believe some of these open practices, collaborative ones, and the open sharing may dilute quality. What's your thinking? Do we think about it as enabling more quality through replication or through larger teams, or do we see a trade-off there, the other three, between the collaborative element and the quality element?
I think it's amusing that you took it's published as a measure of quality. And the peer review process, at least in our field, gives you no guarantee of truth and so every paper, I tell my students, reading rots the mind, right? Just don't believe anything you read until you read it 7 times by 4 different people, then it might be true. And so preprint is just contributing more noise, but it's not a game changer in terms of, oh my gosh, now there's just a flood of junk out there, because the literature is a flood of junk. And so you have to be able to be, have it replicated and over again and in different systems until you can be confident that you file and devote a neuron to that. So don't denote a neuron to any paper unless it's been done lots of times. So it makes it really easy, because you don't have to read that much anymore. You just have to... Yeah.
You can write more papers then.
Yeah, exactly. It doesn't have to be true. You can just write them. There's no, as you say, there's no disincentive to publishing junk.
I think that's a nice way to think about quality, is something that has been replicated and validated so many times that we know more or less that it's right, and literally validated and replicated many times. And not only with the same data, but with different data. And then we can sort of move on and look at other things.
It's kind of
but we don't have to think about just the citations to a paper, which can come from all different reasons, but the degree to which something's been replicated, validated, is probably a good measure of its quality. Yeah. Look how many Toyotas have been sold in the world.
I mean, that's
over and over again. That's replication.
Yeah.
It's
kind of interesting, given that I think we also may see papers here, or certainly in conferences like ours, we see a lot of papers emphasizing the outliers, right? Saying, oh, most papers don't matter, the highly cited ones are the ones we should read. But in some sense, you guys are saying, but that's not sufficient without the other ones, making sure those are actually true. Yeah, and so maybe we have to rethink also kind of what we're looking at. Great comments on, I think, these two guiding themes of incentives. How do these open collaborative practices relate to incentives, but also the quality? I think that was a great setup. Thank you so much, Michaël. I'd now like to open it up to questions, comments from the audience, also online. I think Susanna and Marian took care of the online folks, and it sounds like there's a lot of stuff already, and we'll also collect questions here as well. Marian, do you have anything? Or okay, let's go ahead. Aldo, go ahead.
Okay, a couple of comments. First of all, thanks for the talk, very stimulating. I didn't hear much about fields. It seems that science is one field through this discussion. There, I think you were speaking about management economics, there about medical research, but I think there is a lot of heterogeneity out there for what does it mean, open data, not even open innovation in science. I'm sticking to the old paradigm. Open data, what does it mean, open data in different fields? It's a completely different concept, okay? Sometimes open data are data there that are incomprehensible to anyone else than those people that have produced the data. So the idea itself of open data should be qualified better, or I think I would love to hear some more from the panel. Second point, again, open data is part of science, the argument that you made before, and verification, replication has been there for 150, 200 years, with the connected problem of promotion and tenure and so on and so forth. It's not something new again. It's something that has always been a problem in science, because scientists are there for competition, for reputation, to be the first one. But we do need validation, but it's not new. It's something that science has kind of lived with quite well for the last 200 years. So it's not a big new problem. So I really think that the core problem is here is data dependency. So in the case of economics and management, it was not a problem because we were not using such an amount of data. So creation of a database was mainly economics of innovation. The other economists feel they were not creating data, okay? So now it's becoming more and more common and therefore becomes an issue. So I really think that we really need to carefully look at the dynamic of scientific fields to understand the relevance of data within those fields. And therefore the connected reward system and promotion track. And again, comments from the floor would be very much welcome. 2 more points that I stopped. Sorry, I didn't talk.
You're going to focus on one question for the panel then.
You pick which one you want. Collaboration, university, industry, we already discussed it. For me, it's a bit of a weird combination, speaking of open and university industry. I mean, there the discussion is appropriability, it's not openness, sorry. Is who's going to appropriate rather than not the collaborative research. I would not define it open. By definition, university industry for me is closed, and the major issue how the company is appropriating. And finally, patent publication, the story that the patent is open, yes, but usually patents are written by solicitors, by lawyers, to be impossible to be understood, okay? It's not the scientist that puts time in writing the patent, forget about it. It's the solicitor, it's the lawyer that makes it very, very difficult to be understood. So it's not, theoretically, is an instrument of openness. Practically, is an instrument of appropriation again. So the open instrument there is publication, is definitely not patent. So I would really like to challenge you to take a patent and a publication and give it to a company and see which one of the two will work. I would argue none of the two will work. You need all the rest of the knowledge to do something with it.
Okay, let me suggest not to talk about patents, because Matt did that yesterday already. And I think we kind of know what the disagreements potentially are. I think I would maybe kind of push on the field differences a little bit. And I think Michaël did a good job in kind of showing a 2 by 2 and saying different fields are sitting there. So I think the underlying difference across fields was the speed in which data is generated. I guess maybe also to Michaël's kind of point, I remember I was actually in the Library of Congress at some point, and they were having a discussion. The physicists were saying, we need big servers so we can dump all our data in a shared database. They didn't have the money to actually keep all the astronomical data. And they had no issues whatsoever about other people not seeing the data, because the data are very general in use, which is very different when we do a survey and I have specific questions. I know exactly what papers can be written about this. So maybe another dimension is specificity of the data. Is there anything else, as we get to Aldo's question of what field differences should we be looking at potentially to see whether these tensions are larger or smaller?
Agree that we need to take fields very seriously, and I'm very happy to never use the words basic and applied ever again. But certainly in thinking, in the fields that I look at, the types of data that they use. Are they using reductionist computational data, in silico data, animal models, or are we looking at natural phenomenon in the context? And that turns out to be an interesting division between different kinds of fields that tends to correlate with the speed and cost of data. But I think it's very important to recognize that different fields work on the same thing, and that cross-field solutions are critical to understanding these problems. So it's not one field versus another, but it's all the fields bringing to bear what they have. But
other thoughts on what aspects of fields we should be thinking about?
Well, the summer before I started my PhD, I did a research. I started as a research assistant with Fiona. On misconduct in science. So science is an institution that was created by people. It doesn't have to be the way it is. There was a time before the Office of Scientific Integrity And then we realized that so much work was not only bad, not replicable, but it was actually hurting people. Like, people were just not only wasting $1 million investing on ideas that were shaky, but sometimes just based on just bad science and like wrong results and maybe made up results. So obviously in some fields we really want the data to be right, and like so we made up an institution called this Office on Scientific Integrity. I'm not even sure we have that in Europe, but certainly in the US it's an important thing, and it's good, right? It's a good institution. It's good to have a stick to that lecture to go after some of these bad science things, but it's clearly not doing a great job because there's such a big replicability issue still. So going back maybe to what Michaël was saying earlier, it's just like maybe one of the other side of the middle of all this emphasis on priority is that we want published replication studies, and maybe we should think again about this kind of institutions, providing more incentive for people to do these replications. Might be a solution to. I believe that there is a solution, and that's going to be institutional, but I don't think we have it yet.
So maybe one thing, as we think about fields, that I think about now that I've heard our discussion is that we, as to the extent that we are social scientists, we have to understand our field is also very different from other kinds of fields. And so when we study different sciences, really talking to the local people, and that's a part of co-creation almost as well, can be very helpful and interesting, because some of the things that we think as positive may be seen as negative, or some of the institutional mechanisms that work pretty well in some fields may actually not work in other fields. So that's just in terms of us studying the sciences, being aware that what we assume to be true in our fields may not actually be true somewhere else. But I see there are a lot of questions also online. So Mariam, please go ahead.
I picked one that is very close to the theme of this debate, and it's a question to Dilek, and it says, you mentioned that citizens should capture value from participating. Does this conflict with scientists' goal? If so, how and what to do about it?
I don't think this is necessarily the opposite, or there's like a discrepancy between what scientists want and what the communities want. It's all about, while we are designing our projects and whatever our motivations are, we also need to consider during the design stage what is important for the local communities or for people that we work with. And we talked about the incentives before, right? Why should they participate? Why would they make additional time? And we are all paid scientists, right? We're professional scientists, we're paid for it, but they are not. But they are still making the time and effort to be able to contribute to our research. But why? We really need to understand citizen scientists and their motivations to participate, to be able to give back to them our results. And this could be in the form of achieving change in their local communities, or in the form of acknowledging their contributions by adding them to our scientific papers, if this is an incentive for them as co-authors of our results, right? I hope this answers.
I think one of the history, at least in the United States, has been tremendous ethical misconduct with the use of clinical data. I mean, Tuskegee, for one, that has led to a lot of mistrust on the part of citizens in science. And so this idea that the people who give of their data should also benefit from it has not been historically true. And if it's explicitly built into experimental data, I think that it's important for building back trust, because that mistrust is well-founded on, and part of the reason clinical research kind of disappeared was partly because of these ethical breaches, and now it's very difficult to conduct that research.
It's kind of interesting that you both talked about trust, but different directions of trust. I think your slide was, how can we make sure policymakers trust what the citizens collect and that the data is good quality? You were saying, how can we make sure that the citizens, as in clinical subjects, trust this process enough to actually participate in studies? And I think that's a more general point about these collaborative arrangements, in this case between citizens and science, that we have to trust each other in some sense. And I think going back to the question of goals and incentives, transparency about what each side actually wants from this, and where there might be a conflict is potentially important. Otherwise, it's hard to build the trust, I guess,
and
right?
How many of us don't click accept all cookies because you think, why should I give them my data? And they're going to do something with it, right? Same thing. Yeah.
Well, I think I covered both of the aspects. So when we talk about, as I mentioned before, trust in citizen science approaches and data, we tend to think about the data quality, but we're not looking at the problem from the citizen's perspective, right? We need to, it's a very good point, important point. I totally agree with you that we really need to make sure that if we want to build this trusted environment and our data collection as scientists to be sustainable, then we really need to make sure that citizens are benefiting from contributing to these type of activities or the communities.
Yeah. Great. Other comments from the audience? Questions? Yeah.
Yes. I wanted to add a reflection because I think that we've been focusing a lot when we are talking on open data on the incentives on the motivations, and I think we are doing that because we are thinking about management science, which is quite behind life science. For instance, if there is actually a need to share data, there are mechanisms like embargo periods, I don't know, different even consortiums that are being built with different infrastructures to share data, or journals are actually saying, look, I mean, if you want to publish that, you need to also give us the data. So this kind of mechanisms, actually emerge because we are when we as a community believe that it's important. So I mean, the thing for me in our field in management science is rather the reflection on why do we want this data to be open? So which are the use cases? How can we reuse this data? Actually, is this worthy to storage all this data? So we've heard today some comments of people actually engaging and investing a lot of time opening up data sets that have not been used so much, or we're kind of frustrated about that. So I mean there's MBLVI in life science that are creating this large amount of data because it's being reused. We don't have that, so why? For me that's a more interesting question.
Any responses? If not, we collect a few more ideas, questions.
I actually disagree that there's enough data sharing in life sciences. There is a gold mine of archived clinical trials that would vastly improve drug discovery if we had access to the actual data of the clinical trials, mostly in the private sector, but also in the public sector. So the data that we do see shared tends to be the more reductionist genetic, molecular, chemical data, but that's only a very one piece of the problem. The clinical data is buried deep and needs to be unearthed.
Almost sounds like we need a paper on, it goes back to the field differences as well. What is it about data that makes it worthwhile sharing? How is it potentially being used for replication to build on? How specific is it? So somehow it feels like we are walking around a similar kind of big picture issue, which is what is it about data and the different uses of data? And why does nobody want our data, right? Is it not... I keep telling my PhD students sometimes, that it's amazing how the cycle times in the natural sciences are so fast. Papers get published year after year and you get citations right away. And nobody in our field is 5 years, who cares, right? It's and I don't have the answer for this one, but I keep thinking about why do we take our time? Why is everybody happy with us taking our time?
We're on hard money.
There is a nice question from the online audience that hopefully brings us a little bit away from just talking about data sharing, which is important, but this is more, and this is a question that was particularly addressed to Michael. It says, while it may not pay off to just share data for a PhD student, it may very well pay off to reuse data, or, it goes on, or to use knowledge and resources from others to speed up or improve the quality of their research. How is that part of what you said is the usual way research institutions work and are by definition open institutions?
Yeah. Well, first I really want to say two things. First, the name I was looking for before was Petra Moser, right? So thinking about the alternative as patenting could be secrecy, not just publishing, but it could be all three, right? Anyway, the second thing I want to say is Henry's taking his time. I spent more than 5 years on a paper and I don't take my time. This is how much it takes me to do it. So it's about how do we want... Okay. As a field, there is an input and there is an output. The input is work, and it's money. Let's put it that way, right? And the output is knowledge. How do we think that the right way to use that input in order to maximize output? Right. With all these mechanisms, all these institutions, there are trade-offs that are being made. And so if we decide to say, okay, we're just not going to value data, we make a choice that we want people to invest their time in existing data, and we'll get more patent data papers, right? And there's nothing wrong with it. I use patent data all the time, and that's fine, and maybe that's what we want as a field, but I'm not sure that we all want to look under the same lamppost. And if we do not want to all look under the same lamppost, we need to somehow provide an incentive for people to create a different lamppost. And so that incentive could be, you know, journals, a new journals focusing on data. If that's kind of like the outcome of this conversation, that'd be amazing. But maybe at the end of the day, I don't know that this is we're better off having everybody focusing on theory and no one being rewarded for data work. I don't know. Maybe it is true that we're better off that way.
Yeah, I think what you're speaking about is very small field, right? Which is so. In our field, for example, we've had 10 postdocs doing so-called open lab notebooks, where to test it, instead of, I wonder what happens if share your data in real time. So it's not every day, but once they finish like a 6-week experiment, it takes time, they publish it on a blog. So what I did, put all their data out there, put it on Zenodo, and testing the hypothesis, will they get scooped? Well, and uniformly, it's the opposite. They get telephone calls. Can we collaborate? I see, Rachel, you've made this construct. Could I have it, please? And you send it to them. There's not a single instance of scooping. In the SGC, so for 20 years, we put data in the public repositories, pre-publications. We published 2,000 papers or something. It's not at one time inhibited it. So this sort of specter of someone's going to scoop us, I can count on one hand. 2,000 times it hasn't happened, and once or twice it has.
But if the experiment took 5 years and you're sharing throughout, don't you think the risk of scooping would increase?
In theory, but in practice, we haven't seen it. There's a lot of theory, right, of people frightened. That's what professors are frightened of, being scooped.
No. I mean, sorry. I was really talking about our field. Yes. But I mean, there is a lot of scooping in the life sciences that's been documented. And the paper I'm talking about is not anecdotal evidence. The paper by Megan McGarvey and Caroline Fry on preprints is, you know, I don't know, thousands of papers, etc. All right. So what they found is just this idea that, like, when everybody shares stuff, then people will focus on what is visible to go through the noise. And what going through the noise means, like, reinforcing the Matthew effects, like the richer gets richer even more. So I mean, I think in the it's very hard. Like we were talking about, there is anecdotal evidence on both sides. I've interviewed a number of people talking about twins. Obviously, this is what I've been doing. And you tell me that you never get scooped. Maybe it's.
Well, I mean, what I tell my students, if you can get scooped, that means you're redundant. Choose another field. Right, and then Charles Darwin's got almost scooped by Wallace, right? So you can say that, like, well, Darwin should have just chosen another field.
I think one thing I realize is.
This is a debate.
It's very nice. It's a debate. So that was not staged. This is not a wrestling match where you kind of have, now we have to kind of hit each other. But I think, again, I see, we talk about similar issues, but from different perspectives, different experiences, which is why we have such a diverse panel. But I think at a kind of a meta level, I think it also kind of emphasizes the value of looking at cases where, of course, there's examples for everything, but we also want to be quantitative and kind of descriptive in terms of how often do things happen. And even if it doesn't happen often, it could still be bad enough for the person affected to change incentives, and the anticipation of rare events can be an effect as well. So I think I encourage us all to kind of put all this in our and we will have theories in our head whether you like it or not, in our refined models of how scientists think and how they operate, and kind of put these things in and actually generate research ideas. Michaël, and then we have to close up.
I don't know if there's another question. I just want to make an interesting comparison that in the electronics industry, we see a lot more sort of sharing and cross-licensing and patent pooling and stuff like that. And part of that is because by the time the data get deposited and shared, they've moved on to something else. Whereas in the pharma industry, there's a tremendous crisis of not enough sharing and silos, and they're still living with, sort of blinders on. And part of that reason is it's 18 years, tremendous amount of money, very high rate of failure. And under those different types of circumstances, you're much less willing to contribute to the collective until you've establish something from it, and I think that I'm going to say again, I think the timeline and the obsolescence factor does influence the propensity to share.
Yep. Okay. So speaking of timeline, we have time for one more question. I think. Okay, go ahead.
We still have time. Yeah.
Keep it short, not 3 like Aldo.
Okay, short. No, in terms of like rewarding people for data sharing and so on. So what Michaël was talking about, I have the feeling we think about this in a very black or white way. So indeed, if people have invested 5 years in building a data set, then you force them to share it. I mean, that's not going to work. But then I wonder, like, why don't we borrow more from ideas that they use elsewhere? Like, why not have licenses for specific purposes? Why not force people to give a license for replication purposes, combined with the reputation-based mechanism in science? That's going to work pretty well, I think. So you're going to be pretty much guaranteed that people are not going to steal your data to like write their own paper. You only give them a license to replicate, for example. So if you look at like what happens in software, they have like all this nice menu of licenses, like, oh, you can use it for this or not for that. If you build on my software, you're forced to also make your stuff open and so on. So I was wondering what you think about this. Could that be like an institutional mechanism to deal with this in a more nuanced way?
All right, I think I heard Anesha has one sentence to say, so let's do that as the end of the audience, and then I'll turn back.
So the answer is yes.
Okay. And I mean, if there's someone who is supposed to figure it out, it's a social scientist, I would argue, because that's what we study, right?
Yes, great debate. As we are slowly wrapping up, I just wanted to ask each one of you for a very short recommendation to policymakers, maybe on the national level, how to deal or how to increase incentives for open innovation in science.
More hard money. It's disappeared.
More hard money because it makes us think long term, and we can then share more.
The choices about the science that we do are much less driven by budgets in that sense. Not that budgets don't matter, but the grant renewal, you're one grant renewal away from firing people, and this creates a very different type of environment for doing science than having the old. Back 30 years ago, 75% of scientists were funded by hard money, and that's gone.
Okay, so money's on the list. Let's move to the
next
item.
I would mandate it. It's public money. The 5 years you spent, pretty sure you didn't pay for that out of your own pocket. Yeah, I would mandate it. If it's a public funder, it's our collective data, and it should be shared. And develop the licensing terms and things like that that make it appropriate. But it ain't your data. It's the public's data that you happen to collect on behalf of them.
Dilek.
Thank you.
I think probably mandating for collaborations so that people start really working with each other in a collaborative way for these practices to really happen.
So measures, collaboration measures.
Sort of.
Michaël.
The most difficult task.
Yeah, well, no, I mean, we heard about the stick. I believe in both sticks and carrots, so I'm just going to talk about the carrot part, right? Just like give people credit for publishing data and producing really good data.
Yeah, it's actually interesting. Lars earlier mentioned that many of these things may be driven by the funding agencies prescribing it and doing, and very often we complain about these things, but in some sense it sounds like these things are things that we want to be mandated or some sort of policy framework. And again, I think we'll have some interesting sessions and papers also about the institutional context in which these problems and tensions that we've discussed can be resolved potentially. Because that was kind of the point, not to say, oh, OIS is great, but really to say, what are some of the tensions, what are some of the challenges around incentives, around equality and so on, and how can they look differently across fields, and what can we potentially do about it. So please join me in giving a hand to our 4 panelists. And I have a little helper who will help me hand out a little bit of a thank you for everyone. So this is Dilek. Thank you so much for joining us.
Thank you. Thank you so much.
That's Michelle. Oh, wow. Thank you so much. Yes, you get one too. This Al.
Thank you.
Thank you so much for joining. Who would be the last one? Michaël. Thank you so much.
Thank you.
Thank you. Oh, that's right. And Hila, thank you so much for helping us connect to the TIM division, because it's been great to have so many people obviously in the room, but there's this whole universe of people outside who are listening to us, who hopefully are inspired as well to kind of come up with research ideas based on what we've discussed. And that is great.